Okay, so Cornell Notes topic networks day 2. So again, this is not in the book, so it's a supplement. And the essential question, how do you find a minimal spanning tree of a network? So anytime throughout the notes, I won't say pause every time, but you can pause, just let the sub know when you need it paused so that you can write things down. Okay, so minimal spanning trees, that's our first main idea for today. And how to find a minimal spanning tree. So there are 3 steps. Now, right now, as you write down the steps, probably aren't going to make a whole lot of sense to you until we go through an example. But put the steps down so that when you go home and you need to look back, you can see this. So, step 1, you're going to build the least expensive edge first. So, this means it has the smallest number. It's the smallest number in your network. Number 2, then you're going to build the next edge that is next lowest in cost, or the next smallest number. In the third step, you continue to do this until you have connected all of the edges without creating a circuit. And remember, a circuit from networks day 1 was when you start and end at the same node. That was a circuit. But with this, we cannot create any circuits. Alright, so let's do a couple of examples to see how this works out. So go ahead and pause for a minute and have the substitute pass out the example 1 so that you can paste it in, and then we'll work out the problem. Okay, so it says the diagram shows the costs in thousands of dollars of building walkways between several buildings on a college campus. How can all of the buildings be connected by walkways at the lowest cost? And then we want to know what is the cost. And so basically, this is probably my favorite example of this because then it kind of puts in perspective in the real world where you'll see this or where you'll see that people have used this. So, like for instance, when you go on college campuses, if you've ever gone on college visits, you'll notice that you'll see a lot of college students walking through the grass. They don't always walk on the sidewalks because colleges won't build sidewalks between every single pair of buildings on their whole campus. It would be way too expensive. But they will at least build some sidewalks so that you may have to go a roundabout way if you want to use the sidewalks, and not like walk through the mud. For instance, if it just rained, you don't want to walk in the muddy grass. Then you could follow along. Like if I wanted to get from G to D, but maybe since these are the more expensive ones, they won't build from G to H and then H to D. They may build from G to F and then F to E and then E to D. So you would have to kind of go the roundabout way because that was the least cost for them to build those sidewalks. And so that's where in the real world you'll see some minimal spanning trees when people are kind of developing walkways or whatever it is, something like this. They're going to do it at the smallest cost possible to them. Okay, so step 1 says that I'm going to build the least expensive walkway. Okay, and so out of all of these numbers, 4 is the smallest. And so I would build this one, and I'm going to use a highlighter. I would like to see the path that you're taking, and so make sure that you either use a highlighter or use a pen to kind of cover over, or even your pencil, that's fine. But if you do pencil, make sure you do like little squiggles or something so that I can see that. So I'm going to build this walkway from here to here and from here to here. Those are my least expensive ones. Now you always look, I haven't created a circuit because I can't get from B back to B. You know, I can get from B to C and C to D or other way around, but that's as far as I can go. Okay, step 2 then says to continue and just go in order with your next smallest or next highest to the smallest number here, I guess, however you want to say that. So the next smallest number here is 6 out of the ones left. There's a 6 here and a 6 here. I could build both of those. I could build that one and that one because I have not created a circuit. So I could still get from building H to building E, even though it'd be a roundabout way. I would just have to go this way if I wanted to be on sidewalks. Okay, so there's no closed circuit yet. All right, and then the next number would be 7. So I can build 7 because there's no closed circuit there. So I'm building 7. Then let's see what's after that. 8. Oh, no, yeah. 8 is next. Now, if I build this 8, if I highlight this and build it, I have now created a circuit. And we cannot have circuits. And so I wouldn't build this one, whoops, because it creates that closed circuit there, and we can't have that because they are not going to build this for you as a college student, because you can still get from building B to building H without this walkway. You could go the roundabout way, but you could still use sidewalks to get there. So you can't build that one. So I'm going to cross that one out. Okay. Is there another 8? Nope, that's it. Now the next number is 9. So then I would not build this one because that would create a closed circuit. So I'm going to cross that one out. Now I will build this one because this 9 does not create a circuit. So I will build this 9 because it is not going to create a circuit. It's not quite a circuit here. Okay, so the next number is 10. Now I cannot build this 10 because that would create a closed circuit. I cannot build this 10 because that would also create a closed circuit. So those two 10s are out, so I'll cross those out. But this 10 I would build because there's no way for me to get from G to H yet. G is kind of off on its own little island. So I will build this 10 here. But I'm going to cross out the other two 10s because those create circuits if I build those. So the next number would be 11, but if I build this one, that will create a circuit. I can still get from building G to building B. I would just have to go the long way if I want to be on the sidewalks. And so that's okay because they're going to save that cost. If you can get there, even if it's roundabout, they're going to save some money. And then what else is there? 12? Nope, because if I build 12, I will make a big circuit here. But you can already get from building A to building G. Again, it would be a roundabout way, but they don't care about that. And then I would not build 13 because that would make a circuit. I can still get from building G to building F. I just have to go this route. Okay? So now what you're going to do is all of the walkways that you built, you're going to add those numbers up. So I'm going to come through and circle all those. And then you can put those in your calculator. We got 10, that'll make 20, 39, 46. So that number comes out to be 46. But remember, it said the diagram shows the costs in thousands of dollars. And so in this particular story problem, this would then be $46,000. Because this walkway, to make this walkway was $7,000, this one was $4,000, $4,000, $6,000, so it said it was in thousands of dollars. So how can all the buildings be connected by walkways at the lowest cost? That's what you've got in your picture. So where you cross out some stuff, you highlight or you go over it with your pencil or pen what walkways you're building, and then you add them all up to get your cost. Okay? Alright, let's try another one. So go ahead and pause, and I want you to see if you can follow the steps. So step 1, you build the shortest one first, then continue to go up in number, and only build the ones that do not create a circuit. So pause now. Alright, so let's go through and see what you have. So the smallest number in here is 3. So we gotta start somewhere. So we're gonna start that one. That's the only 3. Okay, next number is 4. So you can build that one because it doesn't create a circuit. And you can build this 4. Okay. Next number is 5, but I can't build the 5 that's off here on the right, because if I built that 5, that would make a circuit, and that's not cost efficient. Any other 5s? Nope. Okay. 6. So, yep, I can build this 6 and I can build this 6 because it won't create any circuits. My highlighter back here. So I would build this, and I would build this one. 7s, nope, no 7s. 8, so yep, I would build this 8. Let's see, ugh, it's not a very good one. And then this 8 though, however, we would not build because that would create a circuit. So we're going to get rid of that one. So get rid of that 8. Can we build this 9? Yep, we can build that 9. So I'll build this 9. And then if I build that 9, I can't build this 9 because that would create a circuit. Now, some people might have built this 9, but then not that one. That's fine. You've actually got a choice here. You would just need one of those. So then I'll cross the other one out. So you make only one of these 9s. 10, nope, I would not do this 10 because it would make a big circuit here if I did that one. This 11, nope, because I would make a circuit here. And this 11, nope, because it would make a circuit here. And this 12, nope, because it would make this big circuit here. So far the numbers I have, I've got 8, 4, 9, 6, 4, 3, and 6. Is that all of them? Okay, so then when you add all of those up, double check the math that I had here on my paper. I get 40. So you'll give me that number. And then this work shows what you would have built. And then this didn't say anything about being in thousands of dollars, so then your minimal spanning tree just has a value of 40. Okay. I think I forgot to say this. I was just going too fast, but this should have been a glue-in that you got. Sorry about that. I forgot to say that. So if not, then hopefully you'll get that. So we'll pass that out for you and you can glue that in. That concludes this video. I'm almost out of time. I only have 15-minute increments of time. And so then for the last 2 examples, examples 3 and 4, we will go ahead and I'll do a different video for that. And while you're switching videos, then the sub can pass out examples 3 and 4 for you so that you can get those pasted in.